So that is called as reinforcement learning. Okay, we had studied the concept of instance based learning in the 6th module, first chapter. So today we will start with some of the second chapter in 5th module. Okay, so that is what is nothing but your reinforcement learning. Okay, so what is reinforcement learning? What are instance based learning? Instance based learning is nothing but at the particular time or at particular instance you need to learn the concepts. Okay, like for example, a baby looking an object, so if you give some value, it gets the data through memory. Okay, so based on the memory we are going to learn, that is called as instance based learning. Okay, apart when we after this chapter we are having the last chapter, that is called is your evaluating hypothesis, which will be finished in 3 to 4 class. Okay, so what are reinforcement learning? So reinforcement is nothing but, so we have studied the concept of neural network, right? So through forward propagation, what happens? The system is going to load the data and train the data set. Okay. Whereas in the backward propagation, the values are going to be passed through backward function. Okay. So based on this, I'm loading the weights or modifying my weights, right? So this is an example of reinforcement. Okay. So in this chapter, we'll be studying about what are agents, what is the state of environment, what are the actions that are need to be taken. So these are the basic three primitives which we are the attributes which will be learned in this function, and we'll be having two functions here. One is reward function and the delay function. So if you have won in a game, like in your IPL game, if the match is won by a particular team, the particular value will be applied onto the particular table, right? Like if the match is up, 1, applied +2. If the match is lost, subtract -2. Okay, so based on that value we are going to give the rewards and delay functions. And okay, next, and here considering the example as my learning robot, so we need to train a robot to automatically learn something based on the games. Okay, so the robot is something acts as agents. So sometimes don't get confused with the words robot and agent here. Both are one and the same. So it has a set of sensors and it is going to predict the particular state of the environment. Okay. For example, we have a camera inbuilt function in our home. Assume we are having automatic camera. Okay. So if any person comes over the near the camera, or so at that time there will be slight changes in the environment. So that will be sent as a notification to our mobile saying that a person is been moving in the particular room. Okay, so based on that environment we can predict some actions. Okay, or a set of actions can be performed based on the particular state. Okay, so here a mobile robot is having sensors and a camera and a sonar data set. Sonar is taken, so to check the conditions or the actions as whether it is moving forward or whether it is turning towards right or left. Okay, so its main task is objective is to learn a strategy or a policy for choosing an action which should satisfy the goal. Okay, for example, if your mobile is battery value is less than 20%, you'll be getting an automatic notification saying that get into power bank or charge the mobile, right? Based on the value that you are going to set through the mobile, it is going to give the notification. So similarly for the robot, there is a docking chamber where the automatic battery charger can be applied when the battery level gets 0. Okay, or simple example is your in your home you will be having your UPS functions, right? So when the automatically when the charge battery level is getting low, automatically the UPS is going to start running. Okay, it need not to be running at every instance. Whenever a particular instance value is being applied, at that time a set of action has to be taken. Okay, so this is regarding your uh, example of reinforcement learning. Why we apply this reinforcement learning? The main intention is to optimize my function. Okay, so if you have studied the concept of operations research, we have or system modeling simulation, we have the concept of automated optimization problems. Okay, so why it is used means mainly the concept of static, to avoid the static programming concepts, and this reinforcement learning will be applied for dynamic programming as well as to solve the optimization problem. So this concept is going to be learned through a separate type of learning called as Q learning. So the algorithm is called as Q learning algorithm, which mainly acquires the optimal control strategies for the delay rewards. Okay. So when we are applying a concept like that, so for the docking function for the battery charger, if it is going to apply a particular charge battery function, so assume apply a positive reward by the value plus 100. If it is not going to charge, give it the value as 0, or okay, or else you can give the negative value also. Okay. So by applying this concept of functions, reward functions, what happens? The robot automatically learns by itself by updating the values in the memories. So here enforcing your system to reload the data or remodify the data for the optimal function. Okay. Hence the word reinforcement learning. Okay. So that's about the basics about the reinforcement learning. Okay. So we have this diagram representation. It's going to be asked, okay, write the reinforcement learning, explain the reinforcement learning with a neat diagram using the concept of agent and environment. Okay. So you can see here the agent is nothing but my robot, and here the environment is the environment which depend upon the application. Okay. So based on the agent, what happens? It's going to check the different, in the environment we'll be having different types of states. So based on the states, we will be applying a reward function for the different state value. So once this data has been loaded through the robot, it automatically learns and it gives a particular type of action to the environment. Okay. So that is represented here like S naught is my initial value and A naught is my action 0 and R naught is my reward value. Okay. So it will be applied continuously to over all the different types of states and for the different types of agents as well as the different types of reward values will be updated. Okay. The main goal or the objective of this is it needs to choose an action for maximizing the solution. Okay. So for that purpose, what we will be doing, the agent should learn the separate control policy. So it should have a control over the different types of states. So that will be represented by the function pi colon S tends to A. So the set of states will be taken by a particular set of actions. Okay. So this type of algorithms or the dynamic programming concept was applied by the scientist SRO. He had solved the problem called Gammon program, where the concept of reinforcement learning was applied for the world-class backgammon players. Okay, so the program used to train around 1.5 million self-automated generated games. Okay, with respect to or equally classified with the best human players in the world. When they play automatically or competitively, the top ranked players were defeated by the system. So hence the concept of this concept came into existence. Okay. So the problem with respect to my learning algorithm is how does the robot has to apply the control policy and how does it choose the actions in such a way that the function should be learned by the control policy. Okay. So based on that, we have three different aspects. One is delay reward, one is exploration, and the other one is partially observable state. Okay. If you study regarding the reinforcement learning, we have two different categories. One is exploration, the second one is exploitation. So exploration means it's going to learn the algorithm or the data set automatically by modifying the values. Whereas exploitation is nothing but for a particular type of instance, the values is going to be delayed or updated automatically. Okay. So this is regarding your delayed reward. So main target function is pi. Okay. And the optimal action is given by represented by A. And for the current state is S. So the equation becomes A equal to pi of S. Okay. So whenever I apply this function, what happens? Suppose if the function is going to get a value of a train or optimal value, the function will be rewarded as a particular value. It should be loaded by the system. Okay. Suppose there's a problem like if the user wants to give a particular value, or instead the trainer needs to provide a sequence of immediate reward values. Like for example, if I have given an assignment to solve, okay, and know if somebody solved it, so I'll be giving one reward for them, like a particular textbook or a particular gift or some other things, right? So based on that, the concept of reward in general, what happens? There will be some trainer where it has to be loaded by the function or the system. Whereas in machine learning, what happens? That there is no need to use the concept of trainer. We can automatically give the values through the programming concepts. So this type of assigning a particular reward through immediate concepts for the agents executing a sequence of actions. Okay. So there will be a problem here. One problem is how does temporal credit or assignment should be given to the state. So what it should do now, so as the values of the states are not yet known at the initial phase. So what I will do take an exam values as 0 at the initial state. If the exploration of the values is going to be taken, so I'll be updating the values in the table. So that will be updated in the table called Q table, and so they based on that value that's going to be updated, the system or the agent will be taking the maximal value. Okay. In general, assume suppose there is a lizard. Okay, and in your home there is a lizard, and in near to that it's having more number of insects. Like towards the left hand side it's having 3 insects, and towards the right hand side it is having 5 insects. Whether the lizard is going to eat 3 or 5, it moves towards the right hand side. That whenever it's having the highest value, or the food is available, towards that it's going to move. Okay, so this is also an example of learning. So based on that, the lizard will take a value saying that the highest values are near to the right hand side, so it goes towards the right hand side. Okay, so this is called as temporal credit assignment. Okay, so next is exploration. So the reinforcement learning distributes the training examples through a separate set of sequence of actions. So this raises a particular type of question. What is it means? How does experimentation produce an effective learning? Okay, for that purpose, we have a trade-off learner where it is going to have favor called as exploration, whether the system has to favor the exploration for unknown states and actions for gathering new data or new information, or whether to use the exploitation of different states and actions which has been already yielded a high reward. Okay, so this is about the two important aspects. And last, we have this concept of partially observable states. We have solved the problems on compiler designs and attack, right? We have solved the concept of DFA algorithm, CFG context-free grammars, and DFA algorithms, and some other different types of attack algorithms where you used to write the partial observable states. Okay, so that is also an example of loading the data only for agents where we are going to apply the concept of sensors. Whenever we apply the concept of sensors to an IoT device or some other device, we are going to give the data sets as partially observable states until the system has to load for maximal optimal solution. Till then, the data will be in partial state. Okay, like a robot which is having a particular forward pointing camera which cannot see the behind it. Suppose if there is an autonomous driving car, and if the camera is being placed at the front of the car, so what happens? It cannot look backwards and get the data. Okay, only the forward movement of my car will be taken for the data set. So this type of data is called as partially observable state data sets. Okay, until it's not yet completed the whole data. Okay, so the last one is lifelong learning. So these type of tasks or the aspects will be applied only for the isolated functions or separate approximation tasks. Okay, for example, a particular robot may need to learn how to dock a battery charger. Suppose if your mobile battery is getting low around 10%, and if you are not at the particular place, automatically the robot has to pick up the phone, and it should automatically plug the docker to your battery charger. Okay, so this type of learning functions will be applied in the machine learning, and this type of learning is called as lifelong learning. And how to navigate through a particular corridor to plug the particular dock to the particular charger for a particular charger. Okay, so based on that value or some of the examples, this concept of reinforcement learning came into existence. Okay, and what is the main importance of learning task? The main importance of learning task is, can somebody tell me what are the recent applications that I told for reinforcement learning? Rajiv?
Sir,
What are the
sir, about the points table you told us, sir, like 2 points if whenever a team wins.
Something about the application? What are the applications that we uh, explained about the reinforcement learning? I gave more around 4 examples in general. What are those?
Sir, one is that points table thing, sir.
Hmm.
Like automatically if a team wins, 2 points are upgraded.
Okay. Next, Ajay. Prajwal. Prajwal. Safana. Shashwata. Shilpa. Neha. Vatsala. Vishnu.
Sir, Prajwal present.
So present alla kana ಕೇಳಿದ್ ನಾನು ನಿಮಗೆ. I asked one question. For that, I need an answer for the question.
Okay, sir.
Okay. Next, we have the concept of learning task. Okay. So in every module, we are having the concept of learning task, right? So here in this learning task, we will be applying the concept of Markov decision process. Okay, it's a mathematical model for the use of reinforcement learning. So sometimes it is called as MDP. Okay. So what it does, it's an agent that perceives a set of distinct states for the environment and particular set of actions, and the environment function will be loaded using the concept of delta through different states. So the data value function is represented of by st comma at, where set of states and particular set of actions for the attributes. Okay. So for the time step t, so here t represents a discrete time event. Okay. So the functions delta and r are part of an environment where the value of the current state and action are going to be loaded at the instance time and not on the earlier state of or the action. Okay. So we consider only this case as non-deterministic functions. Okay. These type of functions are called as non-deterministic functions, but we'll be checking first what is deterministic. So deterministic is nothing but an agent which has to learn a policy for the function phi tends to s of a by selecting a particular type of action for the given observed state. Okay, suppose if you are playing a chess game, if the opponent player is going to play a particular pawn, so you'll be knowing what type of pawn you need to move from your end, right? So that is how the system is going to learn. So this is called as deterministic. Okay, you know what is it needs to be determined by the function. So what happens here? For these type of actions, you will be applying a particular law for the chess event, so that the system is going to give a particular whether you are going to win or lose. Okay. So the main approach is to require my policy or apply the policy which produce a particular reward for the robot. Okay. So that will be applied through the cumulative value called V pi. So V pi of set of states for particular discrete time t step t. Okay, that will be represent approximately equal to RT. So the R is reward plus gamma of RT plus 1. So at the time interval plus 1 plus time interval plus 2, the value of the function will be up in the form of power. Okay, so in general, the value of cumulative value will be represented by v power pi of st approximately equal to summation from 0 to infinity data of the value of this gamma power I into RT. So that's my reward plus of the time interval I. Okay. So here the sequence of rewards will be applied or generated by the states and by repeating the policy function pi. Okay. So the value of that should range between 0 and 1, which is a constant value. And sometimes if the value of that becomes 0 means the immediate reward has to be applied. If it is not 0 or if it is closer to 1, the rewards will be applied at the future time. Okay. So this type of defined by the equation, that is cumulative value, is often called as discounted cumulative reward. Okay. So this is one of the possibility for the events called as deterministic case. For non-deterministic case, what we will be applying is we will be applying the average reward by considering the limit function. Okay, so that will be applied by limit of h tends to infinity equal of 1 by h summation of I equal to 0 power h and RT plus I. Okay, so that is regarding your non-deterministic function. So which gives a maximal optimal function. So that will be represented by pi star approximately equal to argument max of pi function of the cumulative value v of pi of s states s. For all the states, it has to check for the optimal policy. Why? Because it has to learn something or more data has to be trained by the system. Okay. So to illustrate this concept, we have an example called this optimal value function. Okay, which will be discussed in the next class. Okay, and this Q learning. Okay, in next class we will study about water Q functions, water Q learning. Okay, and the problem of reinforcement learning. Okay, that's it for today's class, and thank you.